Guys, somebody sent in a request for solve equations graphically, so just wanted to cover a couple of these examples. This is the first. So anyway, you got two functions here. They want you to graph the two functions. Now the f ones they've already graphed f for you. You just have to graph g, which is this log function, and then later we're gonna have to solve this equation. But right now we just need to focus on graphing this equation. So there's a couple ways to do this. One, if you know anything about graph shifting, this is just going to be your basic log2 function shifted to the left two places. So if graph shifting, you're good at graph shifting, you can do that real easy. Another thing is you can pop it into Desmos and see what it looks like and see if you can grab some points. But one thing you need to know in order to do this is to choose the basic log shape. So this is like a linear graph, right? Oh, it even has absolute value, quadratic, exponential, and then here's a logarithmic. So we want that. Okay. Now, so I gave you two options. You could, be good at graph shifting, or you could pop it in Desmos and see what it looks like. The other option is just to go old school and to start finding points on the graph. So if you think about this, right, what numbers would you like to log base 2? Well, any power of 2 is going to be a nice even number when you log it base 2, because it's just you're asking what exponent would I put above 2 to get that number. So if I take these powers of 2, 1, 2, 4, and 8, right, they're all going to be really nice numbers to log. And I'm going to fill that out next. So, what's log base 2 of 1? Well, that's 0, right? Actually, log base anything of 1 is 0. Now, log base 2 of 2 is just 1 because 2 to the first power is equal to 2. Log base 2 of 4 is 2 because 2 to the second power is 4. And log base 2 of 8 is 3 because 2 to the third is 8. Okay, so that's how I got those numbers. And then I'm just going to figure out what x would have to be so that x plus 2 ends up being these nice numbers. And I just subtract 2 from each of these. So if x is -1, then x plus 2 is going to be 1, right? If x is 0, then x plus 2 is going to be 2. If x is 2, then x plus 2 will be 4, and so on and so on. So these are the numbers I really want to graph, right? -1, 0, 0, 1. Okay. It's also important to note what the vertical asymptote is, right? It's going to be wherever there's, this is going to be 0, because you can't log base anything of 0. Okay. So and 0 is going to happen here at -2. So I can position I think you can control the asymptote here and set the asymptote to be -2. Okay. And then I'm going to look at my points. I've got -1, 0. That's going to be the x-intercept, right? -1, 0. And then I think I have a y-intercept here too. No, I don't. Oh yeah, I do. 0, 0, 1. Right, is where it crosses the y-axis. Okay. Whoop. Didn't quite get that right. Okay, so 0, 1. So now I've graphed it, okay? And I'm ready to move on to the second part of the question, which really asks, well, what if I had an equation where the left side was one of the functions and the right side was the other one? Well, solutions to this equations are just going to be the places where these graphs meet, okay? And we can see that the two places that these graphs meet are here. Whoops. Not meaning to move this point. I'm trying to draw. Maybe you can't draw on the graph. I don't know. I guess not. I wanted to draw a little red around here, but this is where the first place they meet, and here's the second place they meet. Okay. Now, you notice that there's two solutions. They only want one of them, and they want the solution x1 where x1 is greater than x2, which is just fancy math way of saying I want the bigger of the two solutions. So that's going to happen here, of course. Okay, and we think, what's the x value here that makes these two have the same y value or become equal? And it looks like about 2 something. Okay. So within 0.5 units, I'm going to say 2. Okay, so I hope that makes some sense. I'll do a couple other examples so you can see other permutations of the same kind of question.